Hello, hello. Today we are going to be going through the U-substitution method. So this method is basically used for higher order equations. So basically the x power is not 2. The highest power in that equation is going to be more than 2. So for example, x to the power 4 plus x squared plus 2 equals to 0, just like this one right here. Okay, U sub, which that's how I would like to call it, or U substitution, is used for higher order equations. Just going to reiterate that one. It's basically using substitution, so that then the equation, the higher order equation, can be reduced to a quadratic equation, meaning that I'm reducing that x to the power 4 to an x squared. Okay. The reason why I do that is very, very simple. Quadratic equations, they have many methods for me to solve for x, right? So like completing the square is one, quadratic formula is another, and lucky last is PSF. Okay, so it has many methods compared to a higher order equation. So let's go to our example. It says solve the equation x to the power 4 minus 5x squared minus 36 equal to 0. Now, to solve this equation, it's a higher order. So that means a higher order equation. That means I need to reduce it down. To reduce it down, this is what I'm going to do. I'm going to let U, the reason why it's called U substitution, I'm going to let the letter U represent x squared, because I want to reduce anything to its highest power as x squared, right? Makes sense there. All right, so what I'm going to do is, before I even substitute wherever x squared is as U, I'm actually going to break down this x to the power 4 using my indices laws. Okay, I'll write it down first and then I'll explain. So using my indices law, I can break down x to the power 4 as x squared whole squared minus 5x squared minus 36 equal to 0. Now let me explain to you how x to the power 4 can be written as x squared whole squared. Okay, so for example, if I had an equation or a question that says 2 to the power of 3 whole cubed, okay, this indices law is what we call a power onto a power law, okay? So what actually happens, if you remember from year 9 and maybe in year 8 as well, the base is going to stay the same. So the 2 is going to stay the same. Now, what happens with the powers is that if I put a power onto a power, I'm actually going to multiply those two powers in my answer. So in this case, 2 as the base, 2 to the power of 3 times 3. And my final answer is going to be 2 as the base, and the power will be 9. That's basically what I'm using for this here, right? If we were to double check, right, my base is x, that'll stay the same. Then I'm going to multiply 2 times 2, and that gives me 4. Okay, that's how I got it. I'm using my indices law in this method as well. All right, so I've broken it down to x squared. What I'm going to do now is substitute wherever x squared is as the letter u. So this one here is the letter u, and I'll put it as u squared. How I got the squared is from that 2 outside of the bracket. Okay, then I'm going to go minus 5u minus 36 equals to 0. Now my highest power here is 2, right? And that's what I wanted. My highest power to be 2 because it's a quadratic equation. Now, because it's a quadratic equation, I'm going to use PSF because that is one of the methods to solve for a quadratic equation. My product is negative 36. My sum is 5. My factor is, if I trial and error it, it's going to be negative 9 and positive 4. And what I'm going to do is I'm just going to factorize. Okay. Now here it's going to be u, not x. Okay. In each of the bracket, then I'm going to put my factors in. Okay. Once I've got my factors, I'm going to just solve it. Now, before I even solve it, what I'm going to do now is, at this stage, I'm going to resubstitute wherever u is, I'm going to put x squared as, because I'm solving for x, technically, from my original equation. That, I'm solving for x. So I'm going to resubstitute it. Okay, so wherever u is, I'm going to put in x squared. Now, only do it at this stage. Only resubstitute your x squared at this stage here. Okay, once you factorize, then you're trying to find what x is. That's when you resubstitute it. Then just solve. Very, very easy. I'm going to plus 9 on both sides. 9 minus 9 gives me 0. X squared gives equal me to positive 9. Then I'm going to square root both sides to get rid of the squared. Squared and square root cancel out. I'm left with x equal me to, if I put square root 9 into the calculator, I get plus or minus 3. Okay, so that's one solution. Or, let's find out. Put a minus 4 on both sides. Cancel out. X squared equals to negative 4. Now, if I were to square root this here, I can't square root a negative number. So what I'm going to write down now is, therefore, and I'm going to take the or out. I'm going to say, therefore, x squared equals to negative 4 has no solution. We talked about this in discriminants. Yeah. So my answer should only be x plus. My answer must only be x equal to plus or minus 3. That's it. Hopefully that makes sense. If not, rewatch this video as many times as you want until you fully understand it. But other than that, see you. Bye.